Hello everyone, my name is Ye Cao, a master's student from RIOS Lab. Today, my topic is to port Chromium OS on RISC-V. In this project, I'm working with Wei Fu and Yang Liu. They are very experienced software engineers from Red Hat. In these following minutes, I will give a brief introduction about my work, and I sincerely hope you will be interested. My lecture will contain these 5 sections. Firstly, I will start from our motivation about this work, and then I will give a brief introduction about Chromium OS, which we are right now working at. I will then give some reasons on why we decided to start this project and why we choose Chromium OS. We will finally discuss about our methodology for the porting and so far where we are. The motivation of our work comes from PicoReal, an open-source RISC-V platform. Here is the software stack of the PicoReal, as Professor Tan has already showed. As we can see, Chromium OS plays a very important part in the stack, as it provides a rich OS execution environment and is the basis of the Opera web browser app. Due to the special design and strong connection with Chrome browser, this will bring about several advantages, and we will go for it later. After the introduction of PicoReal, we will first come to Chromium OS itself. It's actually the development version of Chrome OS, a very popular OS installed in Chromebook. Chromium OS is a free and open source operating system designed for running web applications and browsing the internet. So with this design goal, the whole architecture can be divided into 3 parts. The lowest level is its custom firmware. The firmware contributes to fast boot time by not probing for hardware, and it also contributes to security by verifying each step in the boot process and incorporating system recovery. Next, at system level, Chromium OS is based on Gen 2 Linux distro, so which a patched Linux kernel. Linux apps are also available to Chrome OS. At user level, what makes it unique is its connection with Chromium web browser. Instead of using desktop apps, Chromium OS uses browser as its principal interface. Web apps are integrated and resemble conventional native applications. They can be launched outside of the Chrome browser. They can be offline by default. They can manage multiple windows and interact with other applications. With these features, you can find that Chromium OS matches PicoReal's features in many aspects. Firstly, Chrome OS is like a web thin client operating system that relied primarily on servers to host web applications and related data storage, as both applications and user data reside in the cloud. For example, Chromium OS includes an integrated file manager, resembling those found on other operating systems, with the ability to display files and directories, and to preview and manage file contents using a variety of web applications, including Doodle Docs and Box. Besides, the support for Linux terminal and applications was already released to the stable channel in Chrome OS. This was made possible via a lightweight Linux kernel that runs containers inside a virtual machine. Secondly, Chromium OS can bring rich software ecosystem to PicoReal and RISC-V. Chromium OS has good support to progressive web applications. Users can simply access the apps through a virtual desktop. Apart from the web apps, Google shows Android applications can run on Chromium OS as well, indicating the linkage from Chromium OS and Android system. Google Play are also available to Chromium OS, which means a variety of mobile apps can be accessible to Chromium OS. Another great feature is the protection of security. Chromium OS includes a trusted boot path, which checks the signature of the code to ensure it's from Google. This verified boot module is contained in its firmware, and we're also trying to port these features to RISC-V. Our work is to port Chromium OS to RISC-V, and we will in some aspects refer to the original SDK. In x86, Chromium OS first built an embedded Gentoo environment and changed into it. These scripts will then build up the toolchains and the overlays. After that, a large number of build packages will be installed and finally built into an image. We will modify this SDK when we port it to RISC-V. Chromium OS is developed from Gentoo Linux, so their package manager are exactly the same. This will give us chances to make some modifications. We use Fedora as our developing environment. Compared to some other popular distros, Fedora has very good support for RISC-V and especially has full support for RISC-V Chromium, which we may need to run through our work. When we start porting, the first thing we need to do is to make a decision between cross-build and native build. Since many packages have different build instructions when using cross-toolchains, and some installations even doesn't have the official support, cross-build seems to become very complex. I had a very failed experience about cross-build, as there are nearly 1,000 packages need importing in Chromium OS, and we found there are too many scripts need modifying, and we finally stopped in the middle. This cross-build procedure was too complex, and we didn't know if there would be some packages that didn't support cross-build at all. In contrast, in our case, a RISC-V tarball of Gentoo on RISC-V has been available for developers, so we can use this tarball to first get into a Gentoo environment in container like Podman, and we can use Chromium user mode to emulate a native RISC-V environment. Of course, this tarball will have some problems since it doesn't been upstream, but for us it's much more easier compared to the cross-build. We use the RISC-V tarball to replace the image and change the working diary into our RISC-V environment. In our next work, we will continuously follow and modify the original SDK. We will have to set up the toolchain and RISC-V overlay. If everything goes well, we will complete the build packages porting at the end of October, and we may successfully run the demo in early November. Finally, I will give a summary about my report. Firstly, we choose the Chromium OS as our rich OS environment for PicoReal, and next, we choose to use native build for our Chromium OS porting on RISC-V. And that's all for my report. Thanks for listening.